So, good day everyone. So, today we're going to talk about the constitutional isomers. So, hi guys, I'm Weljon Oring. I'm from BSA-2C. So, what are constitutional isomers? Constitutional isomers are compounds that have the same molecular formula but different connectivity of atoms. This means the atoms are arranged differently, resulting in different structures and properties. So, kaya daw constitutional isomers ay same molecular formula. Same sa molecular formula, but lahi ilahang structure sa ilahang carbon chain. Like for example, sa butane, so 4 carbon chain, so 1, 2, 3, 4. Instead of straight carbon chain, napas ang isang carbon mahimo niyang substituent. So mo tong example sa constitutional isomers. Para siya naka-branch ng alkanes, like same molecular formula but different structures. Pag ma-different yung structures is lahi na po dihang pangalan. Molecular formula versus structural formula. Molecular formula shows the type and range and number of each atom in molecule. Does not show atoms are connected. So molecular formula daw kanang example lang like C3H8. So muna ang example sa molecular formula nga na. So structural formula shows how atoms are connected in a specific arrangement. Different connection can give different compounds. So like if muna ang carbon chain, muna ang structural kanang carbon chain niya, muna ang structural formula. So why constitutional isomers occur? Carbon can form strong covalent bonds with other carbon atoms in different ways like chain, branch, or position. Ang chain tong ana lang straight, ang branch tong ana tapos na po yung isa carbon mahimong substituent and also the positioning. Functional groups can be attached to different position. So sa asa ma-attach daw ang mga functional groups. Different branching or arrangement give different compounds even with the same molecular formula. Like kung sa pag same lang molecular formula pero ang arrangement nila like maglahi yun. So na mga sample no later sa ato ang discussion ay example sa same lang formula pero lahi sila og name pag mas cluster na sila. Okay, different arrangement naman. So example butane. C4H10. So number 1, in butane straight chain. So mo ni ang example sa butane. So mo na ang carbon chain naka-straight lang siya. So paghapon na to upat na siya carbon 1 2 3 4. Og pag mahimo siyang isomers, matawag siya og isobutane. Og kaning isobutane is branch chain siya nga alkane. Branch chain na siya kay isomer naman. So mo na example, 4 carbon but different structure. Like ang isa carbon, ang pang-upat na carbon is nasa middle part kay nasa taas. Muna pag naming anima, lahi na yung pangalan ay di na siya mahimong isobutane. So ato ang next example is pentane or C5H12. So kaning pentane is consists of 5 carbon. So as you can see in the presentation, so if we count the carbon is 1 2 3 4 5. So there are carbon atoms. And number 2, pag ang mahimo na siya og tagnan na siya mahimo siyang isomers is isopentane tawag niya. So given example is ihapon na tong carbon 1 2 3 4 ang carbon chain niya. Ang isa carbon niya may ang pang 5 na carbon is nakasubstituent sa carbon number 2. So ang iyang pangalan is may mo na siyang 2-methylbutane. Pag nga na dili na siya pentane. Like ang isa man niya carbon, isa ka naman nato gihimo na natog substituent. So dili na siya same dati nga pentane gyapon ang pangalan. May mo siyang 2-methylbutane. Mong to kay lang ang substituent na connect sa carbon 2. Methyl is 1 carbon atom na connect and butane ang longest carbon chain. Number 2 yun, pentane. 2,2-dimethylpropane. So, manong 2,2 ni siya kay mag-start ta og carbon kita tag longest carbon chain is from left to the right. So, 1, 2, 3 carbon chain niya. Nay duha ka methyl nga nag-connect sa center. So, muna ang number 2 na to. Duha siya ka methyl, so 2,2-dimethylpropane. So, here are the 5 isomers of hexane, C6H14. So, hexane is composed of 6 carbon atoms. Number 2, 2-methylpentane. So, sa longest carbon chain is 5 na pentane and na-connect sa substituent sa number 2 mong 2-methylpentane. Number 3 is 3-methylpentane. So, ang substituent niya is na-connect sa middle parts. So, mo ang 3-methylpentane from left to the right ang counting. So, ang number 4 is 2,2-dimethylbutane kaya ang sa second carbon from sa tuang longest carbon chain from left to the right is same into na-connect ang duha ka methyl. So, 2,2-dimethylbutane. And then sa 5 is 2,3-dimethyl. Pwede na asa ka mag-count 3 as a carbon chain mo longest carbon chain. So, upat man ang longest carbon chain. So, butane niya. Ang substituent niya ang alkyl is nasa connect sa 2, carbon 2 o carbon 3. So longest carbon chain. When naming alkanes, choose the longest continuous chain of carbon atoms as the parent chain. So may tawag nimo ang longest carbon chain is meron tong parent. But according to this illustration in the presentation, na mali ang kanang countdown sa carbon kay instead from the right to the left, na yung counting niya is from left to the right. So supposedly ang 1 na diri sa kay number 6 kay diri man sa 6 ang pinakaduol na substituent. So diri ang mahimong 1. So mahimo ni pangalan is 3-methylhexane. So, iupak naming. Find the longest carbon chain. Parent name. Paitaan mo ito. Then, find the chain to give substituent the lowest possible number. So, paitaan mo ito yung substituent kung asa na-attach sa pinakaduol. Name the substituent. So, alkyl group, methyl, ethyl, propyl, butyl. Nang use prefixes like di, tri, tetra. If di is 2, 2 same alkyl, tri if 3 same alkyl, o tetra if 4 same alkyl for identical substituent. Why substituent names in alphabetical order? Like for example, methyl is only 1 carbon and ethyl is 2 carbon. So dapat ang ethyl ang mauna kay E is first than M. Combine numbers and names with commas and hyphens. So if same lang sila, like dash comma, if different na pod, if dash. Kung alkanes, lista na to og ANE sa parent name, like pentane, nag-end siya og ANA. So, physical and chemical properties. Isomers have the same molecular formula but different physical chemical properties. So same na sila og molecular formula but different physical and chemical properties. Kay makalay siya basta isomers, makalay na iyang structure and resulta siyang pangalan, di siya same sa parent. Mausab na siya kay naka-branch naman iyang mga other carbon. Example, boiling point, melting point, density, reactivity, and solubility and odor. So different structure, different intermolecular forces and reactivity. So like structure, may pod mga reaction sa itong mga structure nga nabuo sa tuwang isomers. Importance in agriculture and organic chemistry. Constitutional isomers help us understand the behavior of organic compound in plants, animals, and the environment. So constitutional isomers doon sa katabang sa understand sa tuwang mga behavior sa gaon sa pagkabuhat ang mga compound. Also sa itong mga animals, sa mga animals, plant, and also the environment. They affect the design of pesticide, herbicide, medicide, and fertilizer. So throughout ano mo natin mga herbicide, pesticide, and fertilizer, medicine, tungkol sa mga carbon bonds. So knowing isomers help improve crop protection, drug development, and food quality. So ma-improve sa crop protection kaya natin mga medisina, mga herbicide like that, something like that, and drug development sa pagbuhat sa mga tambal, at sa food quality usaw mo pag-preserve like food harvest. So summary, constitutional isomers have the same molecular formula but different connectivity. They differ in structure and properties. So kailangan sa structure, properties, same molecular formula but different structure. Understanding them is essential in naming compounds. So dapat dinok kung sabtan nato para makabulot sa compounds nga to makam up sa tuwang mga experiment or something like that. And so if help the scientists to identify way easier. It compounds and it in many real life applications including agriculture, medicine, and environmental science. Optional examples, some more examples like propanol, butanoic acid. So mo ni example niya guys, no? As you can see in our presentation. And also kaning mga OH niya is morning mga alcohol. The references, so you can search it on your own because references are already given. So conclusion, constitutional isomers show how different arrangement of atoms create different compounds. Recognizing and naming them correctly is important in chemistry and solving real-world problems. So, moto tong constitutional isomers na. I hope na mo yung sabtan sa kong discussion and that's all. Thank you for watching.